Welcome to Do the Math America. I am Charlene, Math Shaman.
Solving word problems in one variable is found on pages 121 to 126 of the Beginning Algebra book. Please use the link in the description box below this video for the PDF file of the textbook, which you may use to print a hard copy. I will animate the examples for you in this lesson. Solving word problems takes practice and can be challenging, so much so that at times you may need to make multiple attempts. Some of these problems were so challenging even I struggled with them. I did not show you my failed attempts, but the important thing is don't give up. Know that you can solve the problem and keep working until you do solve the problem. If you stick with it, you will gain the satisfaction of conquering a tough problem. Solving word problems in one variable or with one variable. These are the following steps. 1. Read the problem carefully. 2. Choose a variable and assign it to represent the unknown or the answer. 3. Write an equation based on the given fact in the problem. 4. Solve the equation and find the answer. And 5. Check your answer with the problem, usually on a scratch paper. Example 1. 8 less than a number is 18. Find the number. Okay, I will start by assigning the letter n as the variable to represent the unknown, or the number we are solving for. And I do so by writing up on the very top, n equals number. And as I reread the problem on top, the number is means equal. So you always write equal sign when you see is. In this case, 8 less than a number is 18, so I will start by writing equals 18. And 8 less than a number can be written as n minus 8 equals 18. And now we solve the equation by putting the variable on the left-hand side of the equation and all the numbers on the right. We do so by adding both sides of the equation with 8. On the left-hand side, minus 8 plus 8 cancels to 0, leaving n by itself. And on the right-hand side, 18 plus 8 equals 26. So now we have n equals 26. We check our answer. We go back to the original equation, n minus 8 equal 18, and we plug in 26 for the number n. Does 26 minus 8 equal 18? I do that calculation on the side. Or in real life, I would use a separate piece of scratch paper. And I find that 26 minus 8 does equal 18, and so the solution is correct. Example 2. A number increased by 15 is 32. Find the number. Here I will let n equal the number to be solved for. If you notice, I always use a cursive form of the letter to show my variable. Cursive forms of the letters are more distinct from the numbers, making it less likely to mix up letters and numbers in your equations. So n plus 15 equals 32. And now we just need to solve for n by bringing both numbers to the right-hand side of the equation by subtracting 15 from both sides of the equation. On the left-hand side, 15 minus 15 cancels to 0, leaving n by itself, and on the right-hand side, 32 minus 15 works out to be 17. So n equals 17. Now we check our answer with the original equation. N plus 15 equals 32, and we substitute our solution 17 for n. So then we have, does 17 plus 15 equal 32? And I do that calculation on the side. 17 plus 15 does indeed equal 32. Therefore, the solution, n equals 17, is correct. Example 3. Find two consecutive integers whose sum is 37. So on the top, I will write n equals the first integer, and then n plus 1 will be the next consecutive integer. And since we are looking for their sum, that means we need to add both these integers together. So that would be n plus 1. And their sum is 37. We write that as n plus 1 equals 37. And we begin solving this equation by gathering like terms. N plus n equals 2n. So now on the left-hand side of the equation, we have 2n plus 1 equals 37. We bring the numbers to the right-hand side by subtracting both sides of the equation with 1. That leaves 2n on the left-hand side and 37 minus 1 on the right-hand side, or just 36. Now we divide both sides of the equation by 2 to get n by itself on the left-hand side, and on the right-hand side, 36 divided by 2 equals 18. So n equals 18 would be our first integer, and n plus 1 would be 19, which is our second integer. And now we check our answer by adding these two consecutive integers to see if their sum is 37. Does 18 plus 19 equal 37? I do that calculation on the side, and I find that 18 plus 19 does indeed equal 37. Therefore, the solution, n equal 18 and n plus 1 equals 19, is correct. Next problem. Twice the sum of a number and 3 is 22. Find the number. I begin by letting x equal the number we are looking for. So I will write that down as x equals the number. The sum of a number and 3 would be written as x plus 3. I put parentheses around that, and I multiply it by 2 to indicate that twice that sum equals 22. Now I use the distributive property to remove the parenthesis by multiplying both x and 3 by 2, giving us 2x plus 6 equals 22. Next, I bring the numbers to the right-hand side of the equation by subtracting both sides of the equation with 6. So the equation stays balanced, and on the left-hand side, I now have 2x by itself equals 22 minus 6, or 16, on the left-hand side. I divide both sides of the equation by 2 to leave x by itself, and 16 divided by 2, which equals 8, on the right-hand side. Now I check my answer by going back to the original equation. 2 open parenthesis x plus 3 close parenthesis equals 22. I substitute the number 8 for x, simplify within the parenthesis. 8 plus 3, which equals 11, times 2, that does equal 22. Therefore, the solution x equals 8 is correct. Example 5. Find 3 consecutive even integers whose sum is 120. From our previous lesson, we remember that we can notate even consecutive integers as n, n plus 2, n plus 4, and so on. And in this case, we want the sum of these even integers, and so we will add each of them together, and the sum equals 120. And we solve this problem by gathering like terms. So we have 3 n's to be added together, which gives us 3n, plus 2 plus 4, which equals 6 on the left-hand side, equals 120 on the right-hand side. Now we solve the equation by bringing the numbers to the right-hand side of the equation, subtracting both left and right-hand side by 6, which gives us 3n equals 114. Now we isolate n by dividing both sides of the equation with 3. So on the left-hand side, we have n by itself, and on the right-hand side, we have 114 over 3, or 114 divided by 3, which I do the calculation on the side to get 38. So n equals 38. That's our first even integer. The next two consecutive even integers would be 38 plus 2, which is 40, and 38 plus 4, which equals 42. Now I need to check my answer by adding 38 plus 40 plus 42 to see if it equals 120. I do that calculation on the side, and I find indeed 38 plus 40 plus 42 does equal 120. Therefore, the solutions are correct. John has twice as much money as Carol. Together, they have $36. How much money does each have? I begin by letting n equals the amount of money that Carol has. And since John has twice as much money as Carol, 2 times n, or 2n, will equal the amount of money that John has. Together, they have $36, which means that n plus 2n equals 36. And now we solve for n by gathering like terms. So n plus 2n equals 3n, which equals 36. And we divide both sides of the equation with 3 to isolate n by itself on the left, and on the right-hand side, 36 divided by 3 equals 12. So that's the amount of money that Carol has. John has twice that much, which would be 2n, which equals 24. Now we go and check our answer by adding 12 plus 24. Does that equal 36? And yes, indeed it does, which means our solutions are correct. So Carol has $12 and John has $24. We box our answer. A number divided by 2 is equal to the number increased by 2. Find the number. Once again, I will let n equal that number. A number divided by 2 would be n over 2 is equal to the number increased by 2 would be n plus 2. So now I have n divided by 2 equals n plus 2. I begin by drawing parentheses on the expressions on the left-hand side and around the expressions on the right-hand side of the equation, because I need to multiply both sides of the equation with the reciprocal of 1/2, or the number 2. The parenthesis is important on the right-hand side of the equation to indicate that the entirety of the right-hand side must be multiplied by 2. On the left-hand side, the numerator and denominator cancel to leave n by itself, and on the right-hand side, we remove the parenthesis by using the distributive property, multiplying both terms within the parenthesis with 2. Which leaves us 2n plus 4. Now we bring the variables over to the left-hand side of the equation by subtracting both sides of the equation by 2n. In order to prevent crowding my work, I will rewrite this equation, leaving plenty of space to show work. So now I can write minus 2n on both sides of the equation. On the left-hand side, n minus 2n equals negative n. You can think of it as 1n minus 2n equals negative 1n. negative 1 times n equals negative n. So the left-hand side has negative n, and the right-hand side, the 2n minus 2n cancels to 0, leaving 4 by itself. Now we have negative n equals 4. We can multiply both sides of the equation with negative 1. And you see that when we do that, negative 1 times negative n on the left-hand side equals n by itself. And on the right-hand side, 4 times negative 1 equals negative 4, which gives us n equals negative 4. Now we are ready to check our answer by plugging in negative 4 for n in the original equation. We rewrite that equation, n over 2 equals n plus 2, plugging in negative 4 for n, which gives us negative 4 divided by 2 equals negative 4 plus 2. Are those two expressions equal? Well, negative 4 divided by 2 does equal negative 2, and minus 4 plus 2 also equals negative 2. The solution is correct. Next problem. John picked up 2/3 of the books in the shelf. There are 12 books left in the shelf. How many books were in the shelf to begin with? Whenever there is a problem involving fractions, I like to start by drawing out the fraction rod to show the fractions and what it looks like. So 2/3 would be a rod divided into 3 equal parts, and I would highlight 2 of those 3 equal parts to show 2/3. So 2/3 of the books were picked up by John, and the 1/3 of the shelf remaining had 12 books. And we have to solve how many books were in the shelf to begin with. So we start by letting x be the total number of books. So I write on top, let x equal number of books in the shelf to begin with. And I can see from my picture that 1/3 of the books equals 12. And if you remember, the word of means times. So that would be 1/3 times x, the number of books, equals 12. And now we solve for x by multiplying left-hand side with the reciprocal of 1/3, which is 3. And whatever we do on one side of the equation, we balance by doing on the other. So we multiply 12 by 3 on the right-hand side. On the left-hand side, the reciprocals cancel to leave x by itself, and on the right-hand side, 12 times 3 equals 36. Now we need to check our answer and evaluate. Is 36 the total number of books on the shelf to begin with? So we ask the question, 36 minus 2/3 of 36, the number of books that John picked up, does that leave 12 books, which is the number of books left on the shelf? So that equation would be 36 minus 2/3 times 36. Does that equal 12? Begin by simplifying 2/3 times 36. The 3 in the denominator goes into 36, the numerator, 12 times. 2 times 12 equals 24. Does 36 minus 24 equal 12? We do that calculation on the side, and we find that yes, it does. The solution, x equals 36 books, is correct. Roger picked up 2/5 of the books in the shelf. Maria picked up 1/2 of the remaining books. Jack picked up 6 books that were left. How many books were in the shelf to begin with? So there's a lot going on in this problem, a very juicy problem. The best way to approach it is by drawing a picture. So I will draw a fraction rod, dividing it into 5 equal units. I will highlight 2 of those units to show 2/5 of the books that Roger picked up. The remaining 3 units I will divide in half to show the 1/2 of the remaining books that Maria picked up. Jack picked up the other half of those remaining books, and there were 6 books that he picked up. From this picture, we can see that Maria's half also consisted of 6 books. So 3/5 of the total amount of books were the 12 books that Maria and Jack picked up. So now I assign a variable. Let n equal the number of books in the shelf to begin with, or the total number of books. So from the picture, we see that Maria's books and Jack's books would be 6 plus 6 books, or 12 books. I refer back to the fraction rod and mark out the 3/5 of the books that are Maria's and Jack's. And I make note that 3/5 of the total number of books equals 12. 3/5 of the total number of books would be written as 3/5 times n equals 12. So I write the equation as 12 equals 3/5 n. It doesn't matter if you write 3/5 n equal 12 or 12 equals 3/5 n. As long as the equation is balanced, you can place the variable on either side however you wish. Now we solve for n by multiplying both sides of the equation with the reciprocal of 3/5, or with 5/3. On the right-hand side of the equation, the reciprocals multiply out to equal 1. 1 times n is n by itself. And on the left-hand side, we have 5/3 times 12. 3 goes into 12 4 times, so 5 times 4 equals 20. N equals 20. I write n equals 20 books. You should always clearly label the units of your solution. And I box my answer. Now I am ready to check my solution on the side. Or in real life, I would use scratch paper. So I refer back to the problem. Roger picked up 2/5 of the books in the shelf. How many books is that? That would be 2/5 of 20, or 2/5 times 20. If you have been watching all my videos in sequence and doing the practice problems with each video, you should be very comfortable by now doing these types of calculations with multiplying fractions. 2/5 times 20, we see, equals 8. So Roger picked up 8 books, and then we have Maria's books, which were 6, and Jack's books, which were 6. Does 8 plus 6 plus 6 equal 20? And we figure that yes, it does. So therefore, the solution, n equals 20 books, is correct. There are $1 bills and $5 bills in the piggy bank. It has 60 bills with a total value of $228. How many ones and how many fives in the piggy bank? We need to start by labeling our variables. On the top, I write let x equal the number of $1 bills. And since there are 60 bills, the number of $5 bills would be 60 minus x. The value of the $1 bills would be 1 times x. And the value of the $5 bills would be 60 minus x, or the number of $5 bills, times 5. So the equation would look like 1 times x plus 5 times 60 minus x equals $228, or 228. Now we just need to solve for x by simplifying the equation. So 1 times x equals x by itself. We write that underneath on the next line. Plus Use the distributive property to remove the parenthesis by multiplying both terms within the parenthesis with 5. So 5 times 60 equals 300 minus 5 times x, which is 5x, equals 228. I gather like terms. X minus 5x equals negative 4x plus 300 equals 228. Now I bring the numbers to the right-hand side of the equation by subtracting both sides of the equation with 300. On the left-hand side, the 300s cancel, leaving minus 4x. And on the right-hand side, I have 228 minus 300. I do that calculation on the side. When I subtract integers, I need to add the opposite. And when you're adding integers with different signs, you treat it as a subtraction problem. The greater number gives the sign. In this case, the answer will be negative. So 300 minus 228 equals 72. So I have negative 72 on the right-hand side of the equation. I have minus 4x equals negative 72, and I isolate by x by itself by dividing both sides of the equation with negative 4. Negative 4 divided by negative 4 on the left equals 1. 1 times x is x by itself. And on the right-hand side, I have 72 divided by 4. Since the negative signs cancel, it will be a positive number. I do that calculation on the side. 72 divided by 4 equals 18. So x equals 18, which is the number of $1 bills. Now I can calculate the number of $5 bills using the equation 60 minus x, or 60 minus 18. Do that calculation on the side. Always keep your side calculations nearby the main problem so that you can double check your answer. Sometimes those side calculations are where you make mistakes, or so if someone else needs to double check your answers for you. Back in the day when I was learning math, centuries ago it seems, the teachers would always insist that we show our work, meaning show those side calculations before we turned in our homework assignments or our tests. That way the teacher could verify our logic as well as our computations, arriving at our solutions. Okay, back to this problem. Now I've figured out that the number of $1 bills is 18 and the number of $5 bills is 42. So what is the value of 42 $5 bills? It would be 42 times 5, which works out to be 210. And I add 210 to 18, or the value of the $1 bills, to see if it works out to be a total of $228, which it does. So the solution, number of $1 bills is 18, and the number of $5 bills is 42, is correct. I box my answer. The length of a rectangle is 14 centimeters longer than the width. The perimeter is 76 centimeters. Find its length and width. So I draw out a rectangle, and you see that I did use a straight edge. It makes the problem clearer if your picture is nice and clear. And I label the sides. The long side would be x plus 14, and the short side is x. The perimeter is the sum of the sides. The perimeter of any figure is the sum of the sides. And in this case, it's given as 76 centimeters. So I just need to add up all the sides of the rectangle and make sure that it equals 76. So x I will call the width of the rectangle, and x plus 14 is the length of the rectangle. And now I just need to set up my equation, adding the four sides of the rectangle to equal 76. That gives me x plus x plus x plus 14 plus x plus 14 equals 76. Now I gather like terms. There are four x's added together, which gives me 4x plus 14 plus 14, which equals 28. So 4x plus 28 equals 76. Next, I bring the numbers to the right-hand side of the equation by subtracting both sides of the equation with 28. So I rewrite that equation on the next line, giving myself plenty of space to show my work. On the left-hand side, the 28 minus 28 cancels to 0, leaving 4x by itself. And on the right-hand side, I have 76 minus 28. I do that calculation on the side. It equals 48. Now I isolate x by itself by dividing both sides of the equation with 4. 48 divided by 4 equals 12, which is the width of the rectangle, and x plus 14 equals 26, which is the length. So I have x equals 12 centimeters, the width of the rectangle, and x plus 14 equals 26 centimeters, the length. Always write the units of your solution. Now I check my answer by adding the sides of the rectangle to see if it equals 76, or the perimeter. So 12 plus 12 plus 26 plus 26. Does that equal 76? I do the calculation on the side, and yes, it does. So the solution is correct, and I box my answer. A suit is on sale for 20% discount. Roger paid $8.82, including a 5% sales tax. Find the original price of the suit. I will let P equal the original price of the suit. 20% of the original price of the suit is the discount, and we write that as 20% times P equals discount. So if 20% of the original price of the suit is the discount, then the sale price of the suit would be 80% of the original price. And so we write that as 80% times P, which is the sales price of the suit after the discount. Next, we need to account for the 5% sales tax. The sales tax would be attached to the price of the suit at the time of sale. So that would be 5% of the sales price, or 5% times 80% times P. So the equation for the total price of the sale would be 80% times P plus 5% times 80% times P equals $8.82. In other words, the price of the suit after discount plus the sales tax of that price equals $8.82. I begin by converting all the percentages into decimal values, and I use my reference 100% equals 1.0 to remind myself that to convert into a decimal, I need to move the percentage decimal point over 2 places to the left and drop the percentage sign. So 80% becomes 0.8 and 5% equals 0.05. Now I plug those numbers back into the original equation, 0.8 in place of 80% and 0.05 in place of 5%, and I write that equation out on the next line, which gives me 0.8 times P plus 0.05 times 0.8 times P equals 8.82. According to order of operations, I do the multiplication before I do the addition. So I do 0.05 times 0.8 on the side. You can watch my earlier video, Lesson 17, on multiplying decimals if you need a refresher on this skill. 0.8 times 0.05 works out to be 0.04, and I will write that down underneath the problem on the next line. And you can see I write 0.04 directly underneath the multiplication above to show that's the simplified value. And that way you can track your calculation as you go from line to line. Next, I simplify 0.8p plus 0.04p. And sometimes you get confused looking at all those decimals, and maybe it helps to just think of those numbers without decimals. How would I solve that if it were just 8p plus 4p, for example? I know I just need to add those numbers. In this case, even though these are decimals, I do the same thing. I add those numbers 0.8 and 0.04. Gives me 0.84p on the left-hand side of the equation equals 882 on the right-hand side. I isolate p by dividing both sides of the equation with 0.84. On the left-hand side, the numerator and denominator cancel to leave p by itself. On the right-hand side, I have 8.82 divided by 0.84. I do that calculation on the side. If you need a refresher on how to divide decimals, please watch my earlier lesson, Lesson 18, Dividing Decimals. So 8.82 divided by 0.84 works out to be 10.5. So I write that down at the equation. P equals 10.5, or the original price of the suit. So I'm a little limited by my space on this iPad recording system, and so my calculations are a little bit crowded, more so than optimally. In real life, I would use paper and spread out my work. In any case, I write down that the original price of the suit is $10.50, and now I check my answer. So 80% of the original price of the suit was the sale price of the suit. So 10.5 times 0.8 would be how much the Roger paid for the suit. I do that calculation on the side. It works out to be 8.40, so that would be the sale price of the suit. I make a note of that on the side. $8.40 is how much the suit cost. Next, I figure out what is the sales tax, 5% of $8.40. I do that calculation on the side, which works out to be 42 cents. So I add the sale price, $8.40, plus the tax, 42 cents, and see if it adds up to $8.82. And I work those numbers out, and yes, it does work out to be $8.82, which is how much Roger paid. So my calculation that the original price of the suit was $10.50 is correct. I box my answer. A 16-gallon saltwater solution contains 25% pure salt. How much water should be added to produce the solution to 20% salt? I begin by drawing out a picture of a container, and I label it as 16 gallons containing 25% pure salt. What I need to figure out is how much water needs to be added to produce the solution to 20% salt, or how much water needs to be added to dilute the solution to 20%. I begin by labeling my variable. Let x equals the total amount of water to make a 20% solution. And from the problem, we see that what is given is that the 16-gallon saltwater solution was 25% pure salt. So 25% of the 16 gallons is salt. That would be a multiplication problem. 25% times 16 is salt. I simplify this calculation by making 25% into the fraction 1/4. That would be an easier calculation to do than 0.25 times 16. Instead, I just multiply 1/4 times 16, which is 4. So 4 gallons of this solution is salt. Next, we can think of this as a proportional problem. 4 gallons is to how much total solution, or 4 gallons is to x, equals 20% saltwater solution. So the equation would be 4 over x equals 20%. And I start by converting the 20% into a decimal using my reference 100% equals 1.0 to remind myself to bring my decimal points 2 places to the left and drop the percent sign to get the decimal. 20% is 0.2. On the next line, I will write 4 over x equals 0.2 and then solve for x by multiplying both sides of the equation with the reciprocal of 1 over x, which is x over 1. So I will multiply both sides of the equation with x. And on the left-hand side, the x's cancel, leaving 4 by itself. And on the right-hand side, I have 0.2 times x. Now I isolate x on the right-hand side of the equation by dividing both sides of the equation with 0.2. Since I've run out of space on this page, I will have to shift the equation up on the right here and use this opportunity to flip the equation. 0.2x equals 4. Now I continue the calculation by dividing both sides of the equation with 0.2. On the left-hand side, the numerator and denominator cancel, leaving x by itself. On the right-hand side, I have 4 divided by 0.2. I do that calculation on the side on the left here, and that works out to be 20. So 4 divided by 0.2 equals 20. X equals 20, which is the total amount of volume in gallons in the 20% salt water solution, which means I need to add 4 gallons of water to the original 16 gallons of 25% salt to end up with a 20% salt solution. Because 20 minus 16 equals 4 gallons. 4 gallons is the amount of water to be added, and I box my answer. Exercises for this lesson are on pages 125 and 126. Please do as many problems as you need to get a firm grasp of this material, and please check your answers with those in the back of the book, page 302, to make sure you did the problems correctly.
I hope this video was helpful for you. Thank you for joining me at Do the Math America.